we will discuss about this micro engines. So, as far as engines are concerned, so engines are considered to be a kind of a conventional actuator. Okay. So, like it has a potential applications in different fields. So, ideally when we try to scale down these engines on a micro level, so appropriately different complexities comes into the picture. So, one of the complexities includes like in the conventional micro engine there is going to be a combustion. However, when we try to scale it down for some particular application, this combustion should be appropriately replaced by a certain mechanisms. Second thing is like actuation displacement and actuation frequency. Like in most of the engines, like this actuation displacement and actuation frequency are slightly on a higher side. However, for a micron level perspective point of view, appropriately we may need to scale it down for a lower, like a kind of a stick slip effect or a kind of a theta orientation effect needs to be appropriately translated. So, as far as these micro engines are concerned, so these micro engines can be defined as a kind of a micro scale device which are capable of converting various form of energy. So, either it might be an electrical energy or it might be a thermal energy or it might be a chemical energy which needs to be transformed in the form of a mechanical work, or ideally it should be transformed in the form of a motion. So, as far as these micro engines are concerned, so these micro engines are miniaturized power generating or motion producing devices which is operating at a micro scale. So, these devices typically range from few micrometer to several millimeter in size and represent a convergence of mechanical engineering, material science and microfabrication technology. Conventionally, like if we try to look into the mechanical representation of these micro engines, the micro engines are represented in this form. So, one is kind of a translation node, something like this, either it has a movement in this direction or it has a movement in this direction and there is going to be a rotation. This appropriate rotation will help in an appropriate translation in the x direction as well as in the y direction plane. Okay. So, like symbolically the representation of micro engines are represented like this, so that all the x y plane and the theta plane are taken up into consideration. Now, let us classify this micro engines. So, as far as these micro engines are concerned, so these micro engines are classified into two. One is called as a kind of with reference to an energy source and another one is with reference to an operating principle. So, as far as these micro engines are concerned, these micro engines are considered to be highly niche area which has a potential application for with reference to different fields, like some of the field includes swarm robots, micro robots, some of the field which includes a kind of micro energy generators. So, these are some of the fields where such kind of micro engines can be deployed. Now, as discussed, so when we try to classify it, so we are trying to take two different classification. One is with reference to the energy source, another one is with reference to operating principle. So, energy source perspective point of view, so we have the classification in terms of electrostatic micro engines, electromagnetic micro engines, piezoelectric based micro engines, thermal micro engines, chemical micro engines and optical micro engines. So, like in the case of an energy source perspective point of view, like in the case of so electrostatic, electromagnetic and piezo, so where we are trying to incorporate certain amount of actuation principles which is being deployed, and based on this actuation principles appropriately these energy sources are being deployed. Now, with reference to operation principle perspective or point of view also, so we have the optical based system, we have a chemical based system and the thermal based systems which are being deployed appropriately. Now, let us take the first micro engine system which is called as an electrostatic micro engine. So, like as far as electrostatic is concerned, so we have discussed about the fundamentals of electrostatic generation. So, in fact, we have taken an example of a comb drive actuator. So, these micro engines also works on the principle of this comb drive actuator. So, as far as if we try to look into the overall configuration of this, so this is going to be a kind of a fixed electrode. So, in this fixed electrode, so there is going to be a ground pad and this is going to be a cantilever beam electrode. This cantilever beam electrode is going to resonate at a vertical frequency. So, appropriately the ohmic contacts are being established. So, in this ohmic contacts we have a voltage pad, and then there is a cantilever beam based electrode which are being established over here, and then there is a ground pad is there and the fixed electrode is there. So, the cantilever beam electrode will try to move back and forth, and appropriately we can get a kind of an actuation which exhibits. So, like on operation principle perspective point of view, like there is going to be a kind of a Coulomb attraction and Coulomb repulsion which is going to participate for generating for which acts as a base principle for certain amount of application. Basically, it is a kind of actuation which exhibits with reference to this charge device. So, when the voltage is applied, the electrostatic force generated causes a relative motion between the fixed and a movable part. So, in this particular case, so let us take this example. So, F is epsilon A V squared by 2 d squared. So, F is the force which is generated, epsilon naught is the permittivity of the free space. So, ideally in most of the cases, so it will be kind of a vacuum condition or it might be in kind of a controlled environment, and A is the electrode overlap area, and V is the applied voltage, and D is the gap between the distance. So, some of the key advantage of these electrostatic micro engines are concerned. It has an advantage which includes a low power consumption, it has a faster response time, and it has a compatibility with reference with standard microfabrication process. So, like since already there is a well established methodology is there with reference to this electrostatic charge perspective point of view, or with reference to this with reference to the comb drive actuator perspective point of view. So, like based on the appropriate displacement and appropriate frequency, so we can have a control over this overlapping region, so that we can have a kind of a resonant frequency what we are looking for. Now, like as far as application perspective point of view, or with reference to field expertise perspective point of view, so it is mainly meant for producing a small forces, and it also requires a high voltage operating conditions. Now, if we closely observe the design consideration, so the key design consideration for electrostatic micro engine includes an electrode geometry, optimization for force generation, voltage requirements and breakdown prevention, mechanical spring design for restoring forces. So, like we have seen in the earlier case also, so this electrode geometry plays a vital role. So, based on the overall configuration or based on the overall application, appropriately we can have a kind of control over this electrode generation, electrode geometry. Then, like voltage requirement is going to play a vital role. So, ideally like it has a direct relevance towards the power consumption, as well as it also has a direct relevance towards the breakdown prevention. Then we can also have a kind of a mechanical sprint design for restoring the forces, and friction stiction mitigation strategies can also be deployed appropriately. And most important aspect is it has an integration with a control power electronics which can be deployed appropriately. So, these are some of the key aspects, like with reference to an electrostatic perspective point of view. Like these electrostatics has a very less or a very limited focus, or it has a very limited applications, like especially because it produces a very small force, and most of the cases these comb drive actuators are well taken care for different activities related to certain amount of actuations. Now, let us see the next type of micro engine, which we call it as electromagnetic based micro engine. As far as this electromagnetic based micro engine is concerned, as the name suggests, so in this electromagnetic micro engines, so we have the these electromagnetic micro engines utilize the interaction between the current carrying conductor and the magnetic field to generate motion. So, higher force output compared to the electrostatic engines, and electromagnetic engines face challenge with the reference to miniaturization perspective point of view, especially for magnetic component and heat generation from the current flow. So, like one good example or one good practical application with reference to electromagnetic engine perspective point of view is the solenoid configurations. So, as far as in this solenoid configuration is concerned, so we have a kind of a helical coil. So, through this helical coil a kind of an electromagnetic field is applied. This will help the solenoid to move in a micron displacement order. So, in fact, the base electromagnetic micro engines are the solenoids. So, there are wide varieties of combinations in using these solenoid for different displacement. So, if we try to classify this overall configuration of these solenoids. So, one configuration includes the planar spiral coil. So, in this planar spiral coil, so we will be having a core and the coil will be placed over here, and this is the region where exactly magnetic field exists. So, this will act as your solenoid which moves in this particular orientation. Next is called as a helical coil orientation. In the case of helical coil orientation, this will be our core and the helically the current will be placed, and this will be the kind of a magnetic force which will exert for the movement. Then we have this vertical meander coil. As far as in this vertical meander coil is concerned, so we have an arrangement something like this, where the magnetic field will be placed in this particular direction. So, ideally the solenoids are configured with this particular orientation, and the core will try to move within this particular orientation. Okay. So, appropriately, so that we can use it for a kind of a magnetic motion related applications. So, here I is the kind of a electric current which is being deployed, phi is a kind of a magnetic flux. So, based on the application, so we can either go for a planar spiral coil or a helical coil orientation, or we can also go for a vertical meander coil. Okay. Now, let us see the overall fundamentals of this electromagnetic micro engines. So, when we based on the kind of fundamental, so these electromagnetic micro engines are classified under, or based on the kind of principles, these electromagnetic principles are classified under the Lorentz force using a kind of a current carrying conductor. The other one is a kind of a moving magnet approach for permanent magnet excited motor, and the third one is a kind of a variable reluctance principle. Okay. First, let us discuss about the Lorentz force motor. So, as far as this Lorentz force motor is concerned, the force density of a magnetic field is typically decided by a kind of a theory called as Helms-Kortberg and Helmholtz forces. So, that is force. So, basically in case of a incompressible magnetizable media, that is when mu naught is not of f of p, where that is force per unit volume, the Fm is given by J dot B half del mu. So, let us consider a kind of a where mu is the magnetic permeability, rho is the mass density, J is the volume current density, and beta is the magnetic flux density. And H is the magnetic field intensity. So, if you try to use the Lorentz force, let us take an example. Now, let us take the actual system. This is the magnet with north pole, and this is the magnet with south pole. We have a conductor in place, current I and FL. This is going to be the conductor. Okay. And then here the when we try to consider the first term, which corresponds to the Lorentz force, it can be represented as I bar into B bar. I is the electrical current, and the second term describes the force due to a spatial change of the magnetic permeability. So, this is called as a reluctance force. So, in case if we consider it as a kind of a compressible media, then we can call it as a magnetostructive force. Okay. Now, let us take the second concept, which is called as a kind of a permanent magnet based that is a moving magnet approach for a permanent magnet excited motor. Okay, that is it is a kind of an incorporated microfabricated permanent magnet motor. So, if we see the overall configuration of it, let us consider two moving magnets, north pole and south pole, and north pole and south pole. These are the two fixed coils. Which are being placed, and these are the two moving magnets, and this is represented by FL. So, in this particular case, so like this is a kind of an electrodynamic actuation force, which is based on the generation of the Lorentz force on the current carrying conductor due to a magnetic field. So, in case of a permanent magnet excited motor. The Lorentz force results from the interaction of the permanent magnet with the magnetic field of a coil. So, the direction of the generated electromagnetic force depends on the relative orientation of the motor concept of the flux density of a permanent magnet and the direction of the electric current. So, the electrodynamic motor concepts enables a force generation in two directions, that is along the levitation force and one is along the propelling force. So, two design options are possible. So, the moving coil approach where there is a fixed magnet is there, and then there is a kind of a like a moving magnet approach where there is a kind of a fixed coil is there. So, like that we can have a kind of a two different options are possible. Now, let us discuss about the variable reluctance motor. So, in the case of a variable reluctance motor, the variable reluctance motor principle is based on the generation of the force due to a minimization of the magnetic resistance reluctance So, let us consider the reluctance force from the interaction between the surface. Let us consider a configuration. This is a kind of a movable part. So, let us nomenclate it as Ft and Fn. A magnetic flux and this is the fixed part and this is a kind of a coil which established over here, and then we have a movable part in place. So, Fn is the normal force and Ft is considered to be the tangential force. So, in principle the normal forces are much larger than the tangential forces, which causes a kind of a linear or a rotary movement. This aspects needs to be handled carefully in the design of such kind of variable reluctance micromotor, because these kind of variable reluctance micromotors are concerned. So, the concept which has a single gap which suffer from a highly additional friction caused by the drive itself. So, like this is a kind of a arrangement which is being established. So, as far as in this particular case is concerned, like the overall fabrication is going to be a major challenge. So, the fabrication can be appropriately applied by giving appropriate confine to the system, which has a direct relevance towards different applications. So, these are some of the example with reference to an electromagnetic perspective point of view. Okay. Now, let us discuss about the piezoelectric micro engines. So, as far as these piezoelectric micro engines are concerned, so these piezoelectric micro engines harness the mechanical deformation of a piezoelectric material under applied electric field. So, these engines can produce a highly precise high frequency motion with relatively low voltage requirement, and some of the common design which includes basically the ultrasonic motor, that is it uses a kind of a travelling or standing wave in the case of a piezoelectric element, and then it also has a kind of a inch worm related configuration, which is used for employing a kind of a sequential clamping and an extension of a piezoelectric motor. So, like as far as these piezoelectric motors are concerned, it is widely used for micro positioning related applications, like some of the applications include like kind of a micro manipulation or precise positioning, etc. In those conditions, such kind of piezoelectric based micro engines can be deployed. Like but one of the major aspect is like it faces a limitation with reference to the power output and with reference to the stroke length. However, these piezoelectric micro engines can be appropriately like implemented based on the by deploying certain amount of mechanisms, and with these mechanisms we can use it for different functional related applications. So, some of the configurations of these piezoelectric micro engines we will discuss in detail in the upcoming classes.